Hello everybody, hope you can hear me, hope everything is working well. So hello. It feels like Christmas. It's the final day of Advent of Code 2023, even though it's June of 2024, it doesn't matter. It's still nice to finally finish up what I started and finally reach the conclusion of Advent of Code for last year. So there is just one simple, or not simple, but it's last problem to solve. And I thought it would be nice to solve it as a live coding session. Even of course I did pre-read the description and the problem to understand what I will be doing, because otherwise it would be a very boring session of me being completely lost. So I have some idea how to solve it, so we will see if it works out or not. So today's problem, and I hope you can see me, it seems to be streaming correctly. So the problem that we will be solving today is Noverload, and if you hear some noises behind me, it's because of the wind. But we'll have to live through that, because otherwise I would be just completely sweaty, because it's very hot here. So it will be useful to have some air inside. So anyways, Noverload. The problem is basically dealing with undirected graph. Basically, we have a graph of different nodes in a system, and we have a wiring diagram which tells us which nodes are connected to which other nodes. So basically, the input looks like this. We have a node JQT connected to these nodes, and so on. So it's basically a list of nodes connected to other nodes. And our goal and our task here is to figure out which connections we need to break so that those nodes break up into two large groups. And once they do, we need to multiply the sizes of those groups to get the solution to the problem. And basically this tells us that when we disconnect some three wires, it breaks up the graph into two components that are completely unconnected, and each component will have some specific size. And this problem is kind of complicated because it's not just a single wire. If it was just a single wire, you would have to just find that single wire that will disconnect the two components. But it's two. It's not just one. There's not just two, but three wires that we need to cut, which makes things a little more complicated, so to speak. So we need to figure out a better way to do it, and there is actually many different ways. Apparently, there's a lot of probabilistic algorithms that have a certain likelihood to give you the right solution after several runs, or many runs actually, and there is a Kraiger algorithm. I'm not sure if I have it here open. Kraiger's algorithm, which exactly does something like this. It compresses the graph by removing edges and replacing them with one single node. So it basically merges two nodes that are neighboring into one, and it does this over many runs. And as it does this, it always ends up with one single edge, and that single edge over many runs will give you that minimum cut, the most likely edge that will create that cut that can break up the graph into two components. So kind of mathematical stuff, and I don't like that much because I'm not a really math guy that much. So that's one solution. Another solution is visualization, because there are different graphing softwares that can do this. Basically, that you feed it nodes and edges, and it will visualize that graph and then when you see it, you will very, very easily find the right edges to be cut to actually break up into those two components, because apparently the main input, not the small one, but the main input of the problem is very saturated. There is a lot of edges between all of those nodes, so it's kind of easy to see those that are those edges which are actually breaking up to two components. So that's another option. But because of the nature of the input, that there is a lot of connections, it's actually possible to do it in another way entirely, and that's by making by finding the farthest possible nodes that are in the graph, and then removing the path between them, one of the paths between them. And when you do this 3 times, you will definitely remove those bridges that are connecting the two components. So when you do it, essentially you will find the two components, and then you can find the sizes of them. And that's what I will attempt to do here in this session. And we will see if it works out well or not. So gonna be fun. So let's try it. I actually can display this streaming, which will be better, so that you can see any potential chat messages if they come. So let's see. Hopefully it will work. All right. So let's see how we can do this, shall we? So I will take the whole input of the problem, then put it here. And now we need, first thing that we need is to create a class that will store the vertex, the node, and its edges. So I will do public record vertex, which will have a specific name, and it will have list